we're Group 1 and we're going to be presenting you the case of Eden 3D printers. After carefully analyzing the performance of the company, we came to several conclusions and we drew up this report. Starting with the problem statement, we realized that staying competitive in the growing market of 3D printers by using lean production is very important. So the current conditions of the company. Right now, Eden produces 8 printer models, and 5 of them are low cost and cost approximately up to $20,000, and they represent 90% of the sales. While there's 3 custom ordered expensive high-end printers that are only 10% of the sales and are very expensive. However, they are given the priority when they're constructed. Currently, there are 2 suppliers. One is the external supplier, and internal supplier for Eden is Eden itself. They 3D print some of their parts. There are several problems with the external suppliers, such as delays and defects. And when it comes to supplying from internally, Eden takes about 15 to 25 hours to supply the parts. So they all go into the warehouse, and that's where pre-assembly starts. After pre-assembly, there are several points of the final assembly, and altogether this takes about 2 weeks. After all that is done, there's installation, testing, and packaging. However, it is important to point out that 1 out of 10 printers tested are defective, which is often due to the problems within the assembly and within the delays of defects coming from the external supplier. So when all of the products reach the inventory, they're shipped, and in USA it takes about 2 weeks to be delivered, and in the world it takes about 5.
In our assignment, we have focused on the assembly part, and regarding the product, we have focused on the low costs. This seems odd because currently the priority is for the high cost, but we want to change to a mass production. Therefore, we focus on the low cost, which means we can produce more products. It's very important to reduce costs, and we've done this by writing down the 7 ways in the fishbone diagram. We found 5 of the 7 ways in our problem, which can be seen here.
That's good.
When we carefully examined our fishbone diagram, we could come up with countermeasures. However, we have learned from the past. In the 80s, a lot of companies were mass producing. However, this would lead to high amount of inventory and large batches. Therefore, we have learned from TPS, the Toyota production system. We wanted to implement the Toyota production system in our company to increase the flow, which would lead to several advantages in the production system. To increase the flow, we are focused on 4 points. Small production, product focus in no intermediate stock, and no intermediate stock in the single run production. These 4 are all fairly theoretical options. So we have, to make these theoretical solutions more concrete, we try to propose 7 solutions. The first one would be change the external supplier. Currently, the supplier is highly unpredictable, and this will lead to long waiting times, which leads to high costs and unpredictable productions, which is very which is non-beneficial for increasing the flow and having a constant demand. Secondly, we want to apply the U-shape, which can be found in the Toyota production system. With applying the U-shape, we will increase throughput time and lower the waiting times, which would lead to lower costs. Thirdly, we want to assign, instead of 1 team leader, we want to assign 5 team leaders, or a leader to every production site, depending on the number of production of how many products we produce. At the moment, our team leader is not doing a good job in communicating. With implementing 5 team leaders, we will increase communication within the company, and this would lead to better products with less defects.
Okay, a next solution is product plan for every product. This will make sure that there is a constant daily production and that no staff and resources remain unutilized. Next, we have radio communication with team leaders. due to assigning new team leaders, there could arise problems, and by having radio communication, these problems would be known over the entire process, and this will help the entire process. Nextly, we have improved the organization of the shop floor. There is damage, and therefore, due to the damage defects, due to many employees not finding the right tool and using a general tool to fix the product, and this will damage it. And by improving the shop floor and by having the right tools specified per part of the process, this damage will be reduced and the defects will be reduced.
Okay, perfect.
With these 7 proposed solutions, we can get our objectives. As mentioned before, there are several solutions with which we will reduce costs, and we will decrease the throughput time per printer because we have a better quality, which is in line with the third objective, having a high and constant level of quality, which is done by the U-shape and the new team leaders. Regarding the time frame, all these solutions can be done within 3 months. However, the third one, finding and assigning 5 team leaders, is quite hard in the current labor market. Regarding the measuring, we've came up with 4 measuring tools. The first 2 are, let's say, quite obvious, measuring the inventory and measuring the throughput time, which can be found by just measuring. The third and the fourth one are a little bit more involved. The third one is about the video analysis. As we know, proposing a solution is not the same as implementing it. With a video analysis, we will be able to measure the actually used times by employees in all different steps of the process. Lastly, we will do a survey, because the last point in our assignment was that the engineers were not quite happy that we were examining them in their process. Therefore, we want to involve them more in the process, and they might be more happy about us examining them. So the survey will be sent to all the engineers, and they can state different things as employee happiness, but also they can come up with solutions which might be beneficial for the process.